The effect of mutual synchronization is one of the most amazing phenomena in nature and technology. It was first discovered in the 17th century by Dutch scientist Christiaan Huygens, the inventor of the pendulum clock. Once, when he was ill and staying at home, he noticed the strange behavior of his clocks. Pendulums hung on the same wooden beam began to swing in sync over time, even if they initially swung out of sync. It was later discovered that this phenomenon is observed not only in pendulum clocks, but even in fireflies in the tropics and in auditoriums during applause. The effect of mutual synchronization is that even if objects or living beings initially act asynchronously, after a while they begin to work in unison, as if obeying a single invisible rhythm. To test his hypothesis about this feature of the effect, Huygens conducted an experiment in which he deliberately nudged one of the pendulums, disrupting their synchronism. However, after 30 to 40 minutes, the pendulums began to move in unison again, as if there were an invisible connection between them. The scientist suggested that the synchronization was caused by air currents. To rule out this factor, he installed a partition between the pendulums. The result was the same. After 30 minutes, the clocks synchronized again. Ultimately, Huygens concluded that the cause was the transmission of tiny mechanical vibrations through a common beam. This phenomenon became the first documented example of the mutual synchronization effect. As mentioned above, pendulums are not the only ones capable of such amazing self-organization. The synchronization effect can be observed in nature, for example, in the behavior of some species of fireflies in Southeast Asia. In huge colonies of these insects, millions of individuals flash simultaneously, creating mesmerizing light shows. Fireflies adjust the rhythm of their flashes by orienting themselves to their surroundings. When one firefly sees the light of its neighbor, it gradually shifts its own rhythm until everyone begins to flash simultaneously. A similar process can be seen in a concert hall after a performance. At first, people applaud randomly, but gradually the clapping becomes rhythmic. Although no one consciously directs this process, collective applause is organized by itself according to the laws of physics and neurophysiology. A recent study has shown that even the brains of people in happy marriages work in sync. How the synchronization effect works. At the scientific level, this effect is explained by the interaction between oscillators, systems that perform periodic oscillations. Even weak connections between them can lead to coordinated work. Pendulums, fireflies, spectators, they all are oscillators. Mathematical models, in particular the Kuramoto model, describe the behavior of a large number of oscillators. According to the model, if the interaction between elements exceeds a certain threshold, they begin to synchronize without central control. Simply put, each individual element gradually adjusts its rhythm to its neighbors. As a result, the entire system begins to move in unison. The effect of mutual synchronization is important not only in nature, but also in technological systems. For example, electrical networks use synchronization to maintain voltage stability. Biological rhythms of the heart and brain depend on the synchronous work of cells. Even in medicine, studying synchronization disorders helps to better understand diseases such as epilepsy or Parkinson's disease, where excessive synchronization of neurons leads to pathological conditions. To sum up, we can say that the synchronization effect is a demonstration of how complex systems are capable of self-organization without centralized control. It shows that harmony and order can arise spontaneously thanks to simple local interactions between elements of the system. Understanding this process not only helps to unlock the secrets of nature, but also allows us to create new technologies, more stable networks, effective control systems, and even new ways of organizing collective human behavior.